All right. So let me tell you guys what chapter 8 is about. Chapter 8, guys, is about comparing two means, two population means. Let me give you a very important example. Right now, there is a new medication, not a new medication, there's an existing medication that they use to treat malaria. And there's a lot of debate whether this medication works uh, on coronavirus, COVID-19. It's called hydrochloroquine with an antibiotic. There are some people who are saying use this medication, and including the president. And there are other experts who say no, we cannot do that unless we have a study that shows it is effective. So the person, just or the doctors who are saying we cannot use this one until we prove it is effective, they want to do an experiment on it first. So here's how the experiment works. If we do one, and it has to be a large group, just of patients, you will bring two groups. Let's say 5,000 or 500, just each group. One group will get the medication and one group will get the placebo, sugar pill, nothing. And then you administer, the medication on one group and you administer nothing on the other group. And then you compare the results later. If more people, from a group who got the medication become better as a result of taking the medication, then probably we can make a conclusion that the medication is effective. If it is the same percent of people who improve from the group who got the medication and group who did not get the medication, let's say 500 each, and we got like 200 to feel better from one group and about 200 from the other group, then probably you can conclude that the medication is not effective. So this is how you compare two groups. And this is what we're going to be working with today, is comparing two means. In chapter 7, guys, you learned about one mean and one proportion. Now it's going to be comparing two means and two proportion. And this is where most of the time when we do a hypothesis test, we do it actually with two samples. I'm going to walk you through it. There are different tests that we will be using to perform the hypothesis test on two samples. I'm going to start with a little bit of an introduction and tell you what does it mean to have dependent and independent samples. So let's say you get two samples. When do you say that the samples are independent and when do you say that the samples are dependent? I'd like you first of all to see the definition. So we say independent samples if one sample selected from one population is not related to the sample selected from the second population. Look, here is an example right here. They'd have nothing in common. So these are independent sample, but dependent sample, they call them paired or matched samples. Each member of one sample is related to a member from the other sample. And I'm going to give you an example right away on this. You see that there is a relationship between each member of sample 1 and each member of sample 2. Whereas here you see they have nothing in common. Let's take an example. Classify the pair of samples as independent or dependent. You're going to help me with this. Sample 1 is the weight of 65 college students before their freshman year begins. Sample 2 is the weight of the same 65 college students after their freshman year. What do you guys think, dependent or independent, from the definition that I introduced? Any answers? Okay, I see dependent. I agree. These are dependent because it is the same students before and after. So here's the hint for you guys. When it says the same group of people before an action and after an action, you should conclude right away that they are dependent. These are dependent. Let's check the next one. Score of 38 adult males on a psychological screening test for attention deficit hyperactivity disorder. Score of 50 adult females on a psychological screening test for attention deficit hyperactivity disorder. What do you think, guys? It's 38 adult male, 50 adult females. They have nothing to do with each other. So in this case, yes, I agree. I got independent from you. So again, the key, guys, to check if whether the two samples are dependent or independent, if he talks about the same group before and after in both samples, then it's likely that they are dependent. If it is two different groups, definitely they are independent. Okay, let's go to the next page. This is the handout that I sent you last night. I will be sending you also the completed handout once it's done. All right. Here's how we're gonna begin. We're gonna begin with performing two samples. So it's not one sample anymore. Hypothesis test with independent samples, guys. So not dependent, independent samples. To perform a hypothesis test, just like we did, in the previous chapter, there are 5 steps. The first step, guys, is to identify the null and the alternative. But look how easy it is to identify the null and the alternative hypothesis. We do have 2 populations, guys. Population 1 and population 2. Since we're picking 2 samples, so we pick 1 sample from population 1 and 1 sample from population 2. In chapter 7, when we tested the mean, we called it a mu, and we tested a mu. But since we have 2 populations, we're gonna have 2 means. So the first one is gonna be called a mu1, and the second one is gonna be called a mu2. So mu1 is the population, is the mean from population 1, and mu2 is the mean from population 2. Here's how we state the null and the alternative hypothesis. It's always gonna be one of those 3. He either will ask us to check if mu1 is not equal to mu2, so that will be the statement, or he will ask us to compare mu1 with mu2 if mu1 is greater than mu2, and you guys agree with me, if this is greater, this one should be less than or equal to. Or if mu1 is less than mu2, then the null hypothesis will be mu1 is greater than or equal to mu2. So you guys, the first step when you do perform a hypothesis test, comparing 2 means with independent samples, and then is to select one of those. You don't need to think about numbers. There are no numbers on the other side, like in the previous chapter. It's a mu1 and mu2. So you just put a mu1 on the left, you put a mu2 on the right, a mu1 on the left, a mu2 on the right, and then you put the signs. How do you figure out the signs? You will see in the problems. I'm gonna walk you through this. We always assume that the null hypothesis is true until proven otherwise. So this is always the assumption that we made in the previous chapter, and then we make the same assumption in here. So these are the 3 statements. You always select one of those statements when you compare 2 means. Whether sigma is known or sigma is not known, you have to select one of those 3. So you see how simple it is. So I confined, just the first statement into 3 choices. You just pick one of those choices. Let's begin now. In chapter 7, guys, you learned z-test when sigma is known for 1 population mean. Look what it is called now. Instead of 1 z-test, it's called what? 2 sample z-test for the difference between 2 population means. We use z-test in the previous chapter when population standard deviation is known. We're gonna use a z-test when 2 population standard deviations are known. Why 2 population standard deviation? Because I have sigma 1 and sigma 2, 2 populations. So the conditions to perform a z-test. Population standard deviations are known. And what do we call the population standard deviation in this chapter? We call them sigma 1 and sigma 2. Samples are randomly selected. Samples are independent. That's why I introduced a definition of independent. You will be able to tell right away whether the samples are independent or dependent. And the population are normally distributed, or each sample size is at least 30. So either the populations are bell-shaped or the sample size is at least 30. When you meet those 4 conditions, you can perform a 2-sample z-test. And I'm going to show you how to perform the test with an example. Okay. How to perform the test. Verify that sigma 2 and sigma 1 are known. The samples are random and independent. And either the population are normally distributed or N1 is the sample size, the size of sample 1, and N2 is the size of sample 2, greater than or equal to 30. If your population are bell-shaped, you don't have to meet this condition. But if they're not bell-shaped, then each sample size must be greater than 30. And you guys, you already know the 5 steps. State HO and HA. Calculate the test statistic Z. When you did the Z test, it was a Z. Calculate the p-value. Make a decision to reject or fail to reject HO. Interpret the decision in the context of the claim. I don't think this is anything new to you. It's exactly the same 5 steps that you learned before. So what I'm going to do now, guys, I'm going to walk you through an example and show you how to do it. And then the next example, I'm going to have you work with me on this one. So watch. This is the first example. A credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. Can someone tell me what would be the null and the alternative hypothesis here? Yes, because they say they're different. Exactly. Exactly. So let's go over this problem. We'll see how easy it is once we pick up the calculator. So a credit card watchdog groups claims that there is a difference. This is the key word, guys. Difference means not equal to. In the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state. So look, guys, I use N1. We used to use N in chapter 7. Now, since I have 2 samples, I have to use N1 and N2. So what's going to happen, guys, the first sample is going to be labeled 1 and the second sample will be labeled 2. From each state are shown at the left or at the bottom. The 2 samples are independent. Assume that sigma 1. In chapter 7, we have 1 sigma, but look, guys, now to have 2 population standard deviations, sigma 1 is 1,045 and sigma 2 is 1,350 for Illinois. Do the results support the group's claim use alpha equals 0.05? Now the conditions of the test, guys. The condition of the test are met because, let me read the condition of the test. Sigma 1 and sigma 2 are known. Well, they are known in this problem. The samples are random. Well, he says random survey. Watch, look here, random survey. Independent, he says also the samples are independent. And the population are normally distributed, or the sample size is more than 30. Well, we got more than 30, a lot more than 30. We got 250, 250. So the conditions are met. Okay, how do you perform this test? As I said, we're going to be using the calculator to perform this one. Let me show you the screen now on the calculator and show you how to perform this test. Okay, you go to stat, tests. Okay. Any idea, guys, which one is it going to be? It's on the first screen and it's near the top of the screen. We did Z test when we did sigma is known in chapter 7. You can see number 3, it says 2 samples Z test. So it is a Z test, but with 2 samples. So you select number 3. Watch. Stats. Okay. It wants sigma 1. Sigma 1, guys, is 1,045. Now sigma 2, 1,350. then x1 bar, which is 4,777. Then n1, which is 250. Then x2 bar, 4866. N2, 250. And now, guys, before you hit calculate, you need to choose the alternative hypothesis, just like in the previous chapter. And you guys agree with me that the alternative is not equal to. So just do that and watch. Calculate. And bingo. You got Z and you got the p-value. So Z is negative 0.82. I'm going to write this down. And the p-value is 0.4098. So let me write it down. Here we go. We go to the next page and we do the steps one more time. So I'm going to write down HO and HA. Mu1 equals mu2. And here mu1 not equal to mu2. And this is the claim. Z, okay, we used two sample Z test. I'll write it down here. And Z is negative 0.82. P-value is 0.4098. And I think alpha was 0.05. Yes, okay, can you tell me, guys, about step number 4? You should know that because it's something we've done before. So do we reject or fail to reject HO? Fail to reject HO, correct. P-value is more than alpha, fail to reject HO. Now the last statement, which is the important one for a reader. Okay, we fail to reject HO. And our claim is an HA, then we don't support the claim. Again, always when you fail to reject the null hypothesis, guys, that means you're saying the null hypothesis probably is not bad. That means you cannot support your claim. So you say there is not enough evidence at the 0.05 level of significance to support the watch. I'm just going to copy and paste the claim. The credit card watchdog group that there is a difference in the mean credit card debt I know it's a lot of writing between California and Illinois. You just write it, just copy it, guys, and write it down. So this is the conclusion of the problem. Okay, what I'd like you to do, guys, now, I would like you to do the next example. So I'm gonna pause the recording for a few minutes and have you work on this one and see if we will come to the same results. I will read this problem and then we will continue. So a travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. The table below shows the results of a random survey of vacationers in each state. The two samples are independent, so the conditions of the test are met. The samples are random, they are independent, and the population are normally distributed, so the sample size doesn't matter anymore. The table below shows the results of a random survey of vacationers in each state. The two samples are independent. Assume that sigma 1, which is a population standard deviation, guys, so it's a z-test, is 19 for Texas and sigma 2 is 24 for Virginia, and that both populations are normally distributed, bell-shaped. At alpha equals 0.01, is there enough evidence to support the claim? So I didn't make up this example. It was adapted from American Automobile Association. Okay, here's HO, guys, and here's HA. We agreed that mu1 is less than mu2, and this is your claim. So what would be the null? Mu1 is greater than. It's going to be one of those three, guys. You don't have any other choices. There are no numbers to put on the right. It's always one of those three statements. So that's why I told you it's easier this way. Okay, it's a two-sample z-test. So let me run the test, guys. Stat, tests, two samples. Number 3. So section 8.1 is number 3 here. Sigma 1, 19. Sigma 2, 24. X1 bar, $234. N1, 25. I'm just copying and pasting what I see on this and the question. 240. And N2 is 20. And you guys agree with me that we should select the second one. Make sure to press enter. And now go to calculate. And here you go. So your answers were correct. Z is negative 0.91. I'll write it down. And p-value is 0.1808. And p-value is more than alpha. So fail to reject HO. You see, guys, it's redundant from chapter 7. I'm not doing any new techniques to solve this one. Exactly the same as you did before. And then the conclusion. There is not. Remember, every time you have a fail, you start with there is not. I would capitalize this. Enough evidence at the 0.01 level of significance to support the claim that the daily cost of lodging in Texas is less than that of Virginia. Period. Done. There is not enough evidence at the 0.01 level of significance to support the claim that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. Just copy and paste the language of the claim, guys. And that concludes this section. So a summary of this section, guys: perform a two-sample z-test for the difference between two means, mu1 and mu2, with independent samples when sigma 1 and sigma 2 are known. Now you can see the next section is going to be when sigma 1, sigma 2 are not known. So that's what I'm going to be doing next. So that concludes the first one. We'll do some review exercises later, but I'm just going to do one more section and then go back and do a couple review exercises. So let's go to the next section, guys. Let me show you what the next section says. test the difference between means and dependent samples, and you can see just like in chapter 7, sigma 1 and sigma 2 now unknown. Any guess, guys, what would be the name of the test that we'll be using? We use two sample Z test when sigma 2 and sigma 1 are known. What would it be, without looking at the calculator, what would it be if it is sigma 1 and sigma 2? Exactly. I got some people saying two sample t-test. Exactly. It is a t-test for chapter 7, and chapter 8 will be called two sample t-test. As simple as that, guys. So let's see the requirements of the test. Sigma 1, sigma 2 are unknown. We don't have them. The samples are random. The samples are independent. The population are normal, or each sample size is more than 30. So it's the same requirement except for number 1. In the previous one, to use two sample Z tests, you must have sigma 1, sigma 2. Here we will be using a different test. It's called a two sample T test. Sigma 1 and sigma 2 are unknown. So two sample t-test for the difference between means is small independent samples. Verify that sigma 2 and sigma 1 are unknown. The samples are random and independent, and either the populations are normally distributed or both N1 and N2 are greater than 30. You can see, guys, the steps, same steps, no changes. So I'm not gonna change the steps. What I like you, let's see if we still remember how to state the hypothesis together. There were 3 statements. I want to see if we can memorize them by now. U1, mu2, U1, mu2, U2. So let me begin. If this is equal, you agree that the next one will be not equal. That's one statement. Or it could be less than or equal to here. Then the next one will be mu1 is greater than mu2. And I should put or here. It could be mu1 is greater than or equal to mu2, so mu1 is less than mu2. All right. I will come to this in a second here. You're gonna see what this means in a second. Okay, let's do an exercise. It's always easier to explain things with an example. The results of the state mathematics test of random samples of students taught by 2 different teachers at the same school are shown below. Can you conclude that there is a difference in the mean mathematics test scores for the students of the 2 teachers? Okay. Can you guys tell me what would be the null in the alternative hypothesis? Is it the first, the second, or the third? I'll see what your chat is. Does everyone agree with Ryan and Randa? It is the first, I agree. Different means this, guys. And this is the claim, because he says they are different. All right. So that's the first statement. Okay. He says, assume that the population are normally distributed and then population variances are not equal. You will see where we're going to use this one when we perform the test. So let me go to step number 2. So we'll go to sample t-test. Now, maybe students will ask me why it's not 2 sample z-test. This is what I tell the students. I tell the students, look, S1 and S2 are given, not sigma 1 and sigma 2, then you must be a t-test. All right, let's see how we perform the test, guys. We're gonna do that together. I'm gonna turn the calculator on stat, tests, and it's 2 sample t-test. It's not data, I have a summary. When he summarizes in a table, it's a summary, so stats. Okay. He wants X1 bar, 473. It's not a dollar sign, guys. It's a test score, so please ignore the dollar sign here. I made a mistake and put a dollar sign. S1, 39.7. N1, 8. X2 bar, 459. S2, 24.5. N2, what is N2? 18. We need alternative hypothesis here. The alternative, guys, you agree it's different from. Okay, here. Now we're gonna answer this question. It's asking you pooled, yes or no. Look what I said here. Select pooled, yes, select yes if the population variances are equal, and select no if he says the population variances are what? What's the opposite statement? Are not equal. So let's read the problem and see what he says. Look what he says here, guys. So population variances are not equal. So what do you choose, yes or no? So let's see what first students who answer here. No, I agree. Because it says not equal, yes, so you select no. It will make a big difference, guys, in the answers, because there are two different formulas built in here. One formula when we assume the population variances are equal, and another formula when they're not equal. And now let's go to calculate. And here you go, you get T, not Z this time. 0.922, I'll write it down. So here I'm gonna put pooled no, so you don't forget that. 0.922, p-value is 0.3792. It's the day of the null hypothesis. This is bigger than alpha, guys. So what's the decision here? Do we reject HO or fail to reject HO? Fail to reject null hypothesis. And conclusion, my claim is here. If you cannot reject HO, guys, you cannot support the claim, period. So there is not enough evidence at the 0.10 level of significance to support, we're saying we cannot support the claim. The claim that, look guys, I'm not making anything up. I'm just gonna write this down, that there is a difference in the mean mathematics test score for the students of the two teachers. There is, so we're saying we cannot support that. There is a difference in the mean score. So probably the two methods are not any different. Probably they are the same. In the mean score, in the mean score for the students of the two teachers. So if there is a difference, it's not substantial. That's what we're trying to say here. So this concludes the first question, guys. There it is. And I'm gonna take you to another question now. I'm gonna do this together. Okay, let's go back and do this exercise. So I'm gonna read it again. A manufacturer claims that the calling range in feet of its 2.4 gigahertz cordless phone is greater than that of its leading competitor. So you guys agreed that if the manufacturer is mu1, we need to test that mu1 is greater than mu2. That's the claim. And the complement of this one will be mu1 less than or equal to mu2. You perform a study using 14 randomly selected phones from the manufacturer. We decided to label the manufacturer as 1 and the competitor as 2. And 16 from the competitor, so this is where you see it right here. The results from the manufacturer have a sample mean, which is x1 bar. It's not just x bar, guys. It has to be 1 because you have 2 of them. So 1 and 2 always. It's 230 feet with a standard deviation of 26. The competitor have a 216 feet with a standard deviation of 32. At alpha equals 0.05, can you support the claim? Assume population are normally distributed and population variances are equal. Remember, if he says the population variances are equal, pooled is yes. If he says population variances are assumed not to be equal, pooled is no, because you get 2 different formulas. Okay, so it's a 2-sample t-test. Let's do it. So stat. And no more new stuff for today, guys. So that's it. If just those 2 sections. So x1 bar. So it's a statistics. So x1 bar is what? 230. S1 is 26. N1 is 16. Sorry, not 16. 14. X2 bar 216. S2 is 32 feet. N2 is 16. And we need to check that mu1 is greater than mu2. Pooled, that's very important. So we have to select yes here. You try it later with no, guys, you're gonna get different answers. Okay, and then hit calculate and watch. T is 1.303 decimal places, so 303, and the p-value is 0.1017. Degrees of freedom is 28 here. Okay, so let me write it down. So T is 1.303, p-value is 0.1017. We haven't rejected HO today in all the exercises. As I told you, when I make up an exercise, I don't intend one way or another, but it just turned out to be this way. And you guys agree with me, this is bigger than alpha. So your decision is gonna be fail to reject HO, the null hypothesis. We cannot reject the null hypothesis. And thus, the conclusion is there is not enough evidence at the 0.05 level of significance to support. We didn't use the word reject today because all the claims happen to be in HA, to support the manufacturer claim. And what do they claim here? That their calling range, that the calling range of its 2.4 gigahertz phone is greater than that of the manufacturer, of the competitor. That's it, guys. That's the conclusion. And the summary: perform a 2-sample t-test for the difference between 2 means, mu1 and mu2, with independent samples with sigma 1 and sigma 2 unknown. Now, before I wrap this up, guys, I'm gonna scroll toward the end and just do some more examples, and that would be it. So we're not gonna do anything new right now. Okay, let me just tell you something about this. I worked out exercises, one from each section, with calculator screenshots, so that will give you some more support with worked out exercises and the calculator. So make sure to go over those problems. You can see there is one from 8.2. There's one from 8.3, which is we haven't done yet. And there will be one from 8.4, I believe, on the next page. There you go, in color. We're gonna do question 1 and 2, and that would be it. Chapter 8. Question 1, I think, pertains to section 8.1, I believe, and this section 8.2. So let's do those two exercises together. So I'm gonna pause once I read this question. Dr. Smith would like to determine if there is a statistically significant difference between her two math 1800 classes. So what would be the null and the alternative? Can someone tell me what do you think the null and the alternative would be here? A difference. What does a difference mean? It didn't say greater than, it didn't say less than. So would you guys agree it's going to be equal and not equal? That's what difference means. All right. To make this comparison, she will compare the results from exam 1. Class 1 had 30, from exam 1. Class 1 had 33 students take the exam with a mean of 82.6 and population standard deviation of 1.41. So he gives you sigma. So you know it's a z-test, not a t-test. Class 2 had 30. Class 2 had 31 students take the exam with a mean of 84 and a population standard deviation of 3.63. Can Dr. Smith conclude that there is a difference in the mean test grades between the two classes at alpha equals 0.05? Yeah, some students, okay. Let's do this one, guys. Let me set it up and I'll give you time to solve this one. So I'm gonna grab a piece of paper and just try to do it right here. Okay. So we need to test, we have two classes, class 1 exam, class 1 and class 2. So just split it up like that. Class 1, class 2, and that's question 1. Okay, what do we know? Class 1 had 33 students, so you guys agree that N1 is 33. Sometimes he'll give you the table and split them up. Sometimes it's just in the context of the problem, you just have to read it. With a mean of 82.6, so X1 bar, guys, is 82.6. With a population standard deviation, so that's sigma 1, not S1. That's why you have to use the z-test. Class 2 had 31 students with a mean X2 bar 84, and with a population standard deviation of 3.63. Alpha is 0.05, and can Dr. Smith conclude there is a difference in the means? Okay, guys, I'm gonna give you a few minutes to complete the okay. Can Dr. Smith conclude there is a difference? So this is HO and HA. As you can see, the conditions of the test are met, guys. You always have to verify them. But when they ask you to perform a test, the assumption is they are met, the conditions are met. Okay, so let me go to the calculator. See, you're not doing any tedious work by hand at all. Tests, 2 samples z-test. So today, guys, you learned about 2 tests. The first one is 2 sample z-test and the other one 2 sample t-test. That's it. Sigma 1 is what? Let me just go there, 1.41. Sigma 2 is 3.63. X1 bar is 82.6. N1 is 33. If anything not clear, please ask me. X2 bar is 84. N2 is 31. And we need to test that mu1 is different from mu2. And hit calculate. Z is negative 2.01. And the p-value is 0.0445. Yay, we're gonna reject HO this time. All right, I'm done with the calculator, guys. You know this is less than 0.05, and this is how I compare, guys. This 0 is the same as that 0. This 0 is the same as that 0. This 4 is less than 5. That means the whole thing is less. So we reject HO. First time today, we reject HO. And then we state there is, if I show you the question, can Dr. Smith conclude there is a difference? Yes, because we rejected HO, we support the claim. So let me write this down. There is enough evidence at the 0.05 level of significance to support the claim that there is a difference. I'm just gonna copy and paste the language, guys. I'm not gonna make it up. In the mean test grades between the two classes. In the mean test grade between the two classes. There you go. That's it. That concludes the problem. Step 1, step 2, step 3, step 4, step 5. In the book, he uses alpha equals 0.05 when you write it down as a step, but just 5 major steps. That's what you need to focus on, guys. Okay. So that's another review of section 8.1. We're gonna do one more and we will be done, which is question 2, guys. A survey found that the average hotel room in New Orleans is $88.50 and the average room rate in Phoenix is $84.75. Assume that the data were obtained from 2 samples of 55 hotels each, and that the population standard deviations were $5.60 and $4.83 respectively. At alpha equals 0.05, can it be concluded that the average hotel room in New Orleans cost more than that of Phoenix? Okay, guys, what do you think the null and the alternative are going to be? So, a survey found that the average hotel room in New Orleans is $88.50 and the average room rate in Phoenix is $84.75. Assume that the data was obtained from 2 samples of 55 hotels each. Okay, so let's summarize the data that we have here. So we have in New Orleans and we have Phoenix. X1 bar, he says, is 84.75 cents, and X2 bar, which is in Phoenix, no, New Orleans is 88.50, sorry, and Phoenix is 84.75. 2 samples, 55 each. So N1 is 55 and N2 is 55 as well. And population standard deviations. So sigma 1 was 560. If you ask me why I put sigma not S, because he says population standard deviation. And sigma 2 is 483. And this is an indicator, guys, that you have to perform a 2 sample z-test once he gives you sigma. At alpha equals 0.05, can it be concluded that the average hotel room in New Orleans cost more than that of Phoenix? So guys, HO, HA, more than means greater than. We need to check that mu1 is greater than mu2. I mean, if you look at the difference, this is $88, this is $84. So there is a difference. But the question is the difference substantial enough to say that it is really more? We'll see. We need to perform the test. So this is a 2 sample z-test. And I'm done here. Technology is going to help me now. Let's go to the calculator. Turn it on. Clear the screen. Go to Stat, Tests. And then 2 sample z-test, guys. I don't have data yet here, so it's sigma 1. Okay, sigma 1 is, if I look it up, 560. Be very careful as you do data entry. Sigma 2 is 483. X1 bar is 88.50. N1 is 55. X2 bar is 84.75. N2 is 55. And we need to check that mu1 is greater than mu2. Don't forget to press enter when you make your selection before you hit calculate. And let me just scroll here. And you can see, guys, Z is 3.76. And the p-value, oh good, we got the E-5, so we can interpret that. So let me write them down. Z is 3.76, and I'm gonna write the p-value as I saw it here, and then we'll interpret together. So I got 8.476 E-5. Guys, E-5 means it's almost 0, so don't forget about this and don't ignore it. It means you have to move this decimal 0.5 digits to the left. So actually your p-value, guys, is this, which is very small. Once you see E-5, guys, or E-4 and the E-6, make sure it is less than alpha for sure, no matter what alpha is. So we reject HO. And when we reject HO and the claim is in H1 or HA, we support the claim. So I'm gonna write down, there is we didn't have any question today where the claim is in the null hypothesis. There is enough evidence at the 0.05 level of significance to support the claim that, and you just copy it and paste it from that question is, what is the claim? Can it be concluded the average hotel room in New Orleans costs more? The claim that we cannot support the claim, but there is enough evidence, sorry, to support the claim that average hotel room in New Orleans cost more than that of Phoenix. If you reject HO and the claim is in HA, you support the claim. And that's what we did. So guys,